Welcome to your Maths 1 students. We're carrying on our look at binomial expansion, and I left you on a little bit of a cliffhanger yesterday, and I hope you thought about my question at the end of that video, and I hope you were able to see that that notation that we're doing was producing Pascal's triangle numbers. I hope you saw that. We're going to just dig a little bit further in this video as to how that works. So let's just imagine we've got our 1 plus x to the power of 1, and we found that 1 choose 0 is 1 and 1 choose 1 is 1, and we know that in our expansion of this we get 1 plus x, and that is the same as 1 choose 1, which is this blue number here, 1, multiplied by 1 to the power of 1 and x to the power of 0, which is 1. And 1 choose 1 is also 1, and so we've got 1 times 1 to the power of 0, which is 1, times x to the power of 1, which is x. So we get our 1 plus x expansion. A bit weird for that one. Let's try 1 plus x squared. Remember, in Pascal's triangle we have this 1, 2, 1 for when we're expanding 1 plus x all squared. And what you see is if we use 2 choose 0, that gives us a 1, and we times it by 1 squared x to the power of 0, we get this 1 term. When we do 2 choose 1, we get the number 2, and if we times it by 1 to the power of 1, x to the power of 1, we get our 2x term. And if we do 2 choose 2, we get 1, and that's this 1 times we've got here, and we times that by 1 to the 0, which is 1, times x squared, which is x squared. Okay, and the same again with 1 plus x all cubed. So what we're doing is we're taking our q from what we have on the outside of the bracket. So with the cubed, we're going to have 3 choose 0, 3 choose 1, 3 choose 2, 3 choose 3. So from 0 till you get up to the number on the outside of the bracket. That's what we're doing, and that will produce Pascal's triangle numbers for us. So the next row would be, it would be 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, 4 choose 4, and that would give you the next row, which would be, what do we have here? We'd have 1, 4, 6, 4, 1. Okay. So what does this business mean? I mentioned briefly last time that we're talking about combinations here. So let's see if we can figure this out a little bit together. Okay, consider when we expand 1 plus x squared. So 1 plus x all squared, and we can make it out in these green brackets here to be 1 plus x bracket times 1 plus x. With our expansion, we know that there's going to be a term without x's, so you're going to have a term with no x's, so x to the power of 0. You're going to have a term with x's, and you're going to have a term with x squareds in it. You know that's how these expansions work. What we've got to figure out is how many options are there, or combinations are there that produce the desired outcome. So what we want when we're finding out without x term is we've got two ways of picking an x. We can pick an x from this first bracket here, or we can pick it from this bracket here. There are two ways of choosing an x. And out of those ways of choosing an x, we want none of them. So that's why we say two ways, choose 0. Okay? That's how we get no x's, a no x term. But what about making an x term? How many ways could we make an x term? Well, we could make an x term by taking this x here and multiplying it by that one here, or we could do it this way by choosing this x here and that one there. So we say that what we're doing here is there are two x's, and we're choosing one of them. We can choose it from either bracket, so there are two combinations. That's why we get this answer of 2 here. Now, how many ways are there of producing an x squared term? Well, there's only one way. To get an x squared term, we must multiply x by x. There's only one way. And this is why it's 2, choose 2. We need both x's to make an x squared term. So 2, choose both of those x's to make it, and there's only one way you can do that. So that's why we get a 1 times x squared. Let's apply this logic again to the next line, 1 plus x all cubed. And you know when we expand this, we get 1 plus 3x plus 3x squared plus 1. Sorry, 3x squared plus, not 1, plus x cubed. Okay. But 1x cubed. Okay. Alright, well, let's put in our combinations again. How do we get an x term without x's? Well, there are 3 x's and we want to choose none of them. And the only way we can do that is multiply this by that and that by that. There's only one way of doing it, and that's 3 choose 0 there's one way of doing that. Okay, let's move to the next term. We want to make a term with 1x. So this is going to be 3 choose 1. Now how can we make an x term? Well, we could go, we could choose the first one, that times that times that, or we could choose the second one. So we could do this times this times this, or the final alternative is we could do this, choose that times that times that. So there are 3 combinations that will give you an x term. Okay, and what about our x squared term? Well, here we have 3, so, sorry, just going back one, that 3 choose 1 is equal to 3. The next one is 3 choose 2. To get an x squared term, we have to have 2 of those x's multiplied. So 3 choose 2 happens to be 3. Now let me show you why. We need 2 of them. So we could do this times that. That's one way we could do it. Or we could do this times that. Or we could do, what's the other combination that I've missed? We could do this times that times this. And that will give us our 3 combinations to make x squared. Finally, our x cubed. Well, with x cubed, there are 3 ways of producing x cubed. 3, you've got 3 possible ways you can get an x, and you need all 3 of those to make an x cubed, right? The only way to get an x cubed is to times this, by this, by this. Okay. Well, I hope that makes a little bit of sense of these, of the Pascal triangle, and also this n choose r notation that we've just looked into. Again, this is just a precursor. We will cover this a lot more in stats, but so long as you know what we're actually doing here, that will be helpful to you in the next section of work that we're going to cover.